What InstaScope does is it recognizes not only size and shape, but also color. And there are colors that are specific to bacteria, fungi, spores, and things that we care about in the atmosphere when you shine UV light on it. And this essentially captures and integrates that color. That tells us with a high probability whether it's microbes or not. We collect airborne microbes from literally all over the world. We essentially build a catalog of their colors as they age in an aerosol. And we aerosolize in the chamber under many different conditions. Low humidity, we can mimic the top of mountains in here, we can mimic ocean surfaces. We have those types of facilities. There's a broad range of uses, but it all comes back to a catalog that's been built in the lab from microbes that we've captured from the atmosphere, and then that catalog is used as a reference to when we actually use InstaScope to investigate the aerosols in a building. Particle counters have been around for a long time. They're really useful, established technologies that air pollution scientists have used for 20, 30 years, and they're based solely on laser measurements. The difference here is this has other lamps in there that illuminate or induce fluorescence, and biology has a very specific type of fluorescence. This has extra lights in it that laser particle counters don't have, and that gives it the ability to separate biological particles from not. Nobody knows the inventory of airborne microbes in the world, and this allows us to count, size, and at least identify to a coarse level bacteria, pollen, and fungi in near real time. Whereas with static or conventional sampling methods, you have to take it down, send it into a lab, compare it to much smaller numbers, whereas this is comparable to a larger database. This is movable in time and space. We can get an integrated sample in near real time and an idea of the biological load to the total particle load in any environment, outdoors or in. If there's containment or remediation going on, you can show before and after in near real time. And it keeps those working on the site abreast with, are there activities changing the exposure at any given time frame. Traditionally, sampling methods have a lot of subjective issues with them. There's no subjectivity at all. We don't have to look down a microscope and judge, is this a biological particle? Is not. Microscopy can have reasonable confidence towards identifying different species of airborne fungi. That's not always the most important information. What's important is what's the aerobiological load compared to other indoor environments that are similar. InstaScope can give us that information. By and large, that's what